C tutorial 3, we're looking at arrays, strings, and some other fun C stuff.
Let's start off with some comments. Comments are part of your code that the compiler doesn't read as source code. So if we make a main method, int main, parentheses, braces, and at the top of our main method, to explain what this program is going to do, we could write /star, and Visual Studio just automatically finished this comment for me. It put in */. So the start of the comment is the /* and the end is */. So anything between these two isn't going to be read as code when our program runs. The very basic commenting that most professors expect is just your program name at the top of the program, who it was written by, the date it was written, and the purpose of the program. Depending how complicated your program is, you might put these for every single function in the program and not just the main function. So I'll say my program name is tutorial 3. It was written by Nick on February 8th, 2023. And the purpose is to do some comments, arrays, and other stuff. So this is one form of a comment with a / and an asterisk. The other form of a comment in C is a /. So if we write a /, then anything on the rest of the line is going to be a comment. So inside of our main method, say we had a double called temperature. Then to indicate whether the temperature is in Fahrenheit or Celsius, then we can just put a / and put Celsius. So generally for shorter comments, you'll just use a / like this. And then for the longer comments, you'll have the /*, ***. It's good to leave a lot of comments in your code so that for anyone else who comes and reads your program, it's a lot easier to understand. And it's also easier for you to understand if you write it and then come back to it in a few months and you can't remember any of your logic, then you can just read the comments and see what's happening. So it's good to leave a lot of comments, although not too many. You don't want to over comment. So if you have something like int x equals 10 plus 10, and then it's pretty obvious what this line does. It just does 10 plus 10 and puts that value into x. So you really don't need a comment on there that says something like calculate 10 plus 10 and put into x. At that point, it's just kind of overkill and it's a lot to read. Let's make a few arrays now. Let's start with a char array, aka a string. We'll say char my array brackets equals blue. So arrays are just lists of variables. My array is a list of 4 character variables, B, L, U, and E. There's also a 5th element in that list, which is something weird that's just specific to character arrays. C keeps track of where this array ends just by putting a \0 at the end of it. So when we write out our array like this, then what C actually stores is BLUE \0. \0 is the terminating character. It writes like 2 characters with \0, but C actually just reads it as 1 character. So when this program compiles, this will just magically turn into 1 character, which is the terminating character. Let's make an array of ints next. Let's say int array brackets, and inside of the brackets we're going to put the number 50. So this makes us an int array with 50 elements inside of it. And because computers are weird, these 50 elements are numbered 0 to 49. The reason for this just has to do with the way that computers find the memory addresses for elements inside of an array. Pretty much it's just faster for computers to find these addresses if the addresses start at 0. So our int array is just a list of 50 integer variables numbered 0 to 49. And if we wanted to fill up one of these elements, we could say int array 0 equals 16. So now the first element in our array, index 0, has a value of 16 stored inside of it. And then if we wanted to fill up element number 1, we could say int array 1 equals 18. And we could just keep filling it up this way, but that would take a long time. Since there's 50 elements inside of it, we'd need 50 lines of code. So instead, we're going to write a loop that will do it for us. The most common type of loop for iterating through an array like this is called a for loop. We just write the word for, and then in the parentheses, we indicate the variable that we want to use for our loop. I'll say int I equals 0. So that says we're using the variable I for our loop, and we're going to start I at 0. After the semicolon, we put the loop continuation condition, which just says how long we want this loop to keep running for. Let's put while I is less than 50, semicolon. And the last thing that we put inside of our parentheses is how much we want I to increase by for every pass of the loop. Let's just increase it by 1. So for that, we'll put I++. And note that we don't need a semicolon after this I++. Your for loop isn't going to work if you put one after. So we need a semicolon after choosing our variable, a semicolon after our loop continuation condition, but no semicolon after we're saying how much we want I to increase by for every pass of the loop. And then we'll put a set of braces for the body of our loop. Inside of the loop, let's initialize every single element in our array to a value of 0. So we'll put int array the ith element equals 0. And then we'll just put a print statement after our for loop just to indicate that everything went okay and our array is filled up. We'll go printf the array is populated. So we run this and we get build errors. Printf is undefined, so at the top of our program we need our include stdio.h for our standard input and output. Let's run this now, see if we get any more errors. Now it builds successfully and it says the array is populated. So now we have an integer array with 50 elements numbered 0 to 49, and each of those elements has a value of 0. Putting the number 50 inside of our for loop for the loop continuation condition isn't really a great idea, because right now as we have it, if we decided later that we wanted to change the size of the array, and we came in here and put, say, 40, then our for loop now is trying to access elements that don't exist in the array. So now Visual Studio has underlined the int array I inside of our for loop, and if we hover over it, then it says 0 to 49, and then index 49 is out of valid index range 0 to 39 for possibly stack allocated buffer. So it's just saying, hey, don't do this. Your array is only 40 elements long, but you're trying to fill up 50 elements inside of it. That is a bad idea. Above our main method, let's put # define array length in all caps 50 without a semicolon at the end. This is a symbolic constant. What's going to happen is that before this program runs, anywhere where we put the word array length is just going to be replaced with the value 50. So it's pretty much just like a special kind of variable, except it's not technically a variable because it's a constant. We indicate that it's a constant with all caps, which is kind of typical in programming. Whenever something is written in all caps, then it's usually a constant value. So that just means that we're not going to change this partway through our program. So now instead of int array with 40 in brackets, we're just going to put array length. And then we'll use array length again in the loop continuation condition inside of our for loop. The way we had it before, where we just had the value 40 inside of our brackets, people sometimes refer to that as magic numbers. Magic numbers in your program are bad. They're just numbers that haven't been indicated what exactly those numbers stand for. To quote Kernighan and Ritchie's C manual, they say it's bad practice to bury magic numbers like 300 and 20 in a program. They convey little information to someone who might have to read the program later, and they're hard to change in a systematic way. So that's why we use our symbolic constants. Let's make another array now, just to show a different way of making arrays. Let's go int array 2. And this time we're not going to put the length of the array in the square brackets. We're just going to say equals, and then a set of braces and a semicolon. Inside of the braces, we're going to put the values for each element in our array. And then C will kind of infer from that how long we want the array to be. It'll just make it however many elements we put inside of it long. So if we put 20, 40, 24, 35, and 56, then this array is now 5 elements long. And unlike char arrays, there is no terminating character at the end of integer arrays. Char arrays, aka strings, are kind of the one special circumstance where they actually have that terminating character at the end. So this method of making arrays can just be a little bit simpler sometimes. If you know you only want a few elements in your array and you know what those values are, then you can just write it all on one line of code. One of the inconvenient things about arrays is that you have to know how long you want your array to be when you make it. In one of the future videos in this series, we're going to look at how to make a dynamic array, which is just an array that changes in size according to how many elements you want to fit inside of it. I'll link to that video in the description once it's up for anyone who's not going through these videos in order, if you want to go check out how to make a dynamic array if you're interested. That's it for this video. Thanks for watching. I'll also put some links in the description to some resources for learning C, just some of my other videos, and some good books to read for learning C.